will proceed in vector and commercial calculus. Vector and energy calculus, the topic in which we are pursuing the discussion. Vector and energy calculus. Vector and commercial. Vector and commercial calculus. Okay, so we have reached till flux, and then we have reached till flux density. And then if I know flux, then I can calculate flux density. Flux density is same as divergence. Flux density is same as divergence. Whereas, okay, so what I'm trying to say is, okay, quickly we will kind of revisit. If there is a liquid, if there is a liquid and liquid is flowing, okay, there is a river. Okay, before that, okay, anyway, we'll see. There is a river. There is a river and river is flowing. So there is a river. There is a river and river is flowing. If river is flowing, then I'm just going to keep this inside the river. And question arising is how much volume of water is crossing this plate. Okay, this is a kind of okay, this is a kind of wooden plate, and how much is the water that would cross this wooden plate if I keep it inside the water? There is a river and river is flowing like this, and I'm going to keep it, and how much water is crossing? Okay, then I would, this is area vector. This is area, and area vector is perpendicular to the area. Area vector is perpendicular to the area, whereas the curve vector is along the curve. Very nicely we have seen it. Okay, very nicely we have seen it. If this is a curve, if this is a curve, if this is a curve, then curve vector is along the curve. But if it is the area, then area vector is perpendicular to the area, not along the area. Not along the area, perpendicular to the area. Perpendicular to the area is the area vector, whereas along the curve is called curve vector. This is what we have seen. If I am going to keep this inside a river, then if this area vector is in direction of water, then maximum water will pass through. How much water will pass through? If I know how much water is passing through, I know the area, I can calculate the water velocity. If I know water velocity and certainly I know the area, then I can calculate how much volume of water that is passing through per second. So that is called flux. Flux of this plate, and with respect to a water in a river or liquid that is passing through. If I keep any electrical source, electrical charge somewhere, from there electrical field is flowing. Electrical field can also be considered an electrical field liquid. And how much liquid is passing through it, then velocity of the liquid here and multiplied by the area is the net liquid that is passing through the surface. That is called flux. Okay, if liquid velocity is v, if I keep this in river and this is the velocity of water, then this has to be, the area vector has to be in direction of the water. If I keep like this and water is flowing like this, then nothing will pass this surface because velocity vector is perpendicular to the area vector. Nothing will pass, or maximum it will pass. If I tilt it, then whatever is the angle between the area vector and angle between the velocity vector, if you take the cos theta dot product, then it will, if you take the dot product of the velocity vector and area vector, that will be the flux. Velocity vector dot area vector is the net volume that is coming out of it. If If velocity vector is not a straight line, what do you mean it is not a straight line? Velocity vector may not be a straight line. Vector means a straight line, but there can be algebraic vector which is a bunch of vectors, where bunch of vector in bunch in a bunch of vectors. If I call it bunch of vectors, if I call it bunch of vectors, then bunch of vector, then in the bunch, each vector is produced if I take some value in the algebra, that is the algebraic vector. Minus yi plus xj is the algebraic vector. Keep changing y and x and keep getting new vector. Keep changing y and x and keep getting new vector. So that is called algebraic vector. Now, if I say that my vector field is a numeric vector, means vector field has components x, y, z component and all are numbers. If my vector field is algebraic vector, then x, y, z component all are algebra. Keep the different value of x, y, z, keep getting different vector. Okay, like if I keep an electric charge here, electric charge here, electric charge here, then the vector field due to electric charge will be radial all along. And equation is, consider equation is r vector, but the velocity vector of electric charge, the electromagnetic radiation that is coming out of the vector, that is coming out of the electric charge is q, that is the electric charge, r vector divided by r to the power 3, means it is going all around. In that sense, if I keep a plane like this, then if electric charge is kept here, then here it will touch this vector. Here there will be another vector because it is centered at this point. Because it is centered at this point. Here I am keeping this point. Here the electric charge will be like this. The liquid from electric charge. Everywhere it is different if you see. If vector is different at different point and I want to do nomenclature to the vector, then it will result into algebraic vector. Okay, then it will result into algebraic vector. Like qr vector divided by r to the power 3 is q xi plus yj plus zk divided by x square plus y square plus 3z square to the power 3 by 2. Means everywhere the electric field vector, velocity vector is different. Then you multiply by the area vector. If you multiply by the area vector at each point of the area, electric field velocity is different. That is a big concern. And there, now we land up into basics of algebra. Numerical science is fixed. I am getting 10 mango, means 10 mango. It is not less than that, it is not more than that. But beyond that, I am getting x mangoes. X mango. Now x can be 1, 2, 3, 4, infinite. X can be 1.5 also. So the when things are variable, changeable, when things are changeable, I have two person in front of me. One person I am giving X mango, another person I am giving 2x mango. Doesn't matter how many I am giving. But what matters is that I am giving double of him. Two person A and B is standing in front of me. And to A I am giving X mango and to B I am giving 2x mango. No one is worried about how much you are giving. It is they are worried about what time another is getting from the first one. So if I am saying one person I am giving 2 mango, another person I am giving 4 mango. Okay, then people will just see how many times he is getting. Rather, I would say if I am giving one x mango, another is getting 2x. So when the numeric is not that much significant, we use variable, that is algebra. Okay, now if I have something called multiplication, this is x 2x. Now let's multiply. I have given many times this example. Now let's multiply x into x, then it is x square as per the algebra. But if one x is dependent upon other x, okay, like I'm trying to calculate the area of this. area of this. Consider this is x-axis and this is y-axis. This y-axis is fixed. See, consider this height is 2. Then at any x, if I want to calculate the area, then from origin to x, then left side, this is the area I am trying to calculate. X into 2. X into 2. That is the area. Okay. Now consider I'm trying, if this is x, if this is x, consider this is also x. Then if I'm trying to calculate area, then it is x into x. X square is the area. This is this is a square. But consider one x is dependent upon another x. Now instead of saying y as a separate entity, this is separate entity, this is separate entity. Now I'm saying here the y, the height is fixed. You go along x-axis anywhere, this height is fixed. Okay, the area of any shape, areas of any shape is width into height. So area of this is width into height, where width can be variable but height is constant. What about height is variable? Okay, and height is variable in the sense of width only. Like, like if this is x-axis, then at the origin height is 0. If this is x-axis at x, height is also x. If I go and here I say it is 10, then height is also 10. In that sense, the flat line what we were seeing as y, that was the height. Now y is variable now. Can you see? If y is dependent upon x, again the height is x. The height is x and width is x. But height is dependent upon width. If width is any x, then at that moment, if this is the x, then height is also x. At this moment, width is x, but this is the x, height is also this much only. Height is dependent upon width. Height is dependent, height is y. Now, y I can say, since it is dependent upon width, I can say it is function over x. Function over x-axis. What is the area? Area is width into height. Area is y into x, but y is fx, function over x. Fx into x, fx into x is the area. What is the area? Fx into x. If fx is a constant, here it was a constant and that height was 2, then 2 into x is the area, any x. X is variable. But the height is function over x and it is not constant, that is fx. Then area is again fx into x. So tell me what is the area? Fx into x. What is the, but if I replace this fx with any term as x, either sine x, x square, x, whatever it is, then area will not be direct multiplication. It won't be fx into x and fx is x, then x into x is the area. This is called abstract notation. What is your area? Area is width into height. Width is x at any point, then height is fx at any point. If fx is constant, then height is constant at any point. Then you can do 2 into x is the net area. But if it is fx is a function over x and that is not a constant, then direct multiplication will not work. Direct multiplication will work in an abstract notation. Fx into x is the area. Okay, consider fx is x. Fx is x. If this is x-axis, this is fx. Height is changing upon the x. Now fx is x. If fx is x, then x into x will not give you area. In that sense, fx into x becomes fx dx. D is the integral sign we place in between because the height is function over x. If height is function over x, then net area is fx into dx. One d symbol we place it saying that it is dependent and independent and dependent algebra is there. If algebra is further developed into independent and dependent component, then direct multiplication will not work. So fx into x is wrong word. Fx into dx, that is correct word. Now fx is x, then x dx. This is the net area. Net area is width, that is dx, and height is x. Now net width, net area is x dx, x square by 2. That is the net area. This is the fundamental. Anyway, we will proceed through. Now, if I know flux, now consider I'm covering this energy calculus in very deep extent because this is the root of artificial intelligence. If someone do not understand energy calculus, then because it has everything, it has vector, it has algebra, it has calculus, it has numerical science, everything this has. Anyway, now consider there is a charge here, electrical charge here, and this is the electrical field all around. And there is a surface like this. Now, electrical field is passing through this surface. What is the flux of the surface? Flux of the surface means how much electrical field is coming out of the surface. But problem is electrical field from this side it is entering into the surface, and this side it is coming out of the surface. So net flux will be whatever is coming out of the surface is plus, and what is entering is minus. If plus minus plus and minus, if I settle down, and if it is not zero, positive, then this surface area has positive flux. It has positive flux. Now, what if it has a positive flux? Means flux, the velocity vector, velocity or liquid that is entering or electromagnetic wave or electrical wave that is entering the surface from here and it is coming out from here. If net coming out is more than going in, then there is a positive flux. Positive flux divided by this volume is flux density. Flux density means flux is volume per second divided by the volume, that is per second. Flux density means if this has volume of v meter cube, then per meter cube how much is the flux? That is flux density. Net flux divided by the volume means per unit of volume what is the flux? That is the flux density. And it is same as divergence that we know. Divergence means at a particular point inside this sphere, there is a point in the sphere from which energy source is also there. Because of one energy source, I am seeing the electromagnetic field is passing through. But whatever is entering and whatever is exiting, if exiting is more than entering, there is a chance, there is a high chance that inside this sphere there is one more electrical charge kept there. Because of that, flux is positive. The net flux coming out of it is positive. There is a high chance. This leads to a concept of divergence. Divergence in the sense, like consider there is an electric field that is passing along the x-axis. This is x-axis, this is y-axis, this is z-axis. One electric field is passing along x-axis. Now it is kept at the origin. Exact half of it is along the minus x-axis, exact half of it along positive x-axis. This half flux is positive, this half flux is negative. Anyway, because the liquid is entering, here liquid is exiting. If liquid exiting at higher velocity, because this surface area what we are talking, right hand side and left hand side, they are exactly same. It is kept at the origin and liquid is passing on the x-axis. If the velocity of the liquid that is coming out of this is more than that is entering, means certainly there is an energy source kept inside it. If that is the case, if the capital F vector is the velocity vector, then df by dx is there. Df by dx is there, means velocity is changing along x-axis. That's why the velocity at which it entered this shape, it exited from the shape with higher velocity. Means that inside it at the origin, there is an energy source that is diverging energy, and it is diverging the electrical field or electrical field liquid, and liquid that is coming out is more, velocity is more. If velocity is more and surface area is same as this side, then flux will be more. Minus, plus, minus, net flux is high. Net flux is high because this velocity is, when it is hitting the surface, then it is slowly it is growing, and when it is coming out of it, it has more velocity. df by dx is positive. df by dx is positive. When df by dx is positive, means they at the center inside it there is an electrical charge is kept and it has divergence. It is throwing liquid. That's why df by dx is positive. Anyway, now we understood that flux density, that is the net flux divided by the volume, it is same as divergence. If there is a velocity field that is capital F and it is equal to F1i plus F2j plus F3k, then the net divergence is dF1 by dx plus dF2 by dy plus dF3 by dz. All three components first get the divergence along the x-axis, along the y-axis, along the z-axis, and that df by dx plus df2 by df1 by dx plus df2 by dy plus df3 by dz is same as you calculate the flux around this around the surface of this volume divided by the volume. Now question is arising, consider I have a, but if you see, if you calculate the flux, then velocity vector and area vector both come into the picture, divide by the volume. Velocity vector, velocity vector and area vector, if they are multiplied, you get the flux, divide it by the volume. Still in the calculation, we have the shape of the volume that comes into the picture. But if you see the same formula of flux density to divergence, then df by d1, df1 by dx plus df2 by dy plus df3 by dz, where f1, f2, f3 are three components of velocity vector. Means if I know the vector field or velocity vector from electrical charge, I need not know the surface at all. From the velocity, like if there is an electrical charge kept and velocity, the like liquid that is emanating, electromagnetic liquid that is emanating from this electrical charge is q into r vector divided by r to the power 3. If I want flux density, then I need not know any surface at all. This is df1 by dx plus df2 by dy plus df3 by dz. How much f1 is changing along x-axis, that much liquid is getting added at some point. At some point, df1 by dx will be algebra, df2 by dy will be algebra, df3 by dz will be algebra. Since it is not a vector, we can add it and it is a full-fledged algebraic function. In that sense, if I want to calculate the divergence at a point, now I am trying to calculate at point 2, 0, 0, is there any energy source or not? Because my df1 by dx is positive, it is not 0. If df1 by dx means there is a velocity vector for which x component, f1. X component is changing along x-axis. df1 by dx, its y component. Along y-axis also it is changing. f2 is changing. df3, that is z component, is also changing if I go along z-axis. df1 by dx plus df2 by dy plus df3 by dz. If a whole is positive, if whole has an algebraic equation at a certain point, it is positive. Sir, consider all three comes at, consider there is an electric field called x square I plus y square j plus z square k. What is the net flux density? What is the divergence? That is df1 by dx, 2x plus 2y plus 2z. Okay, now calculate the divergence at the origin. At the origin, silently, in hidden way, I did not tell anyone, there is an electric field passing through, and its equation is x square I plus y square j plus z square k. At the origin, silently I placed one more electrical field. I did not reveal it to anyone. What is the divergence of that electric field? How much more electric field it is generating and adding it to whatever we have? Then at net, what is the net divergence? Net divergence is 2x plus 2y plus 2z. At origin, net divergence is 0. At the origin, there is no net change that is seen in df1 by dx plus df2 by dy plus df3 by dz. Means at origin, there is no energy source kept at all. What about 2 comma 0 comma 0? Then it will be 4. Yes, at 2 comma 0 comma 0, there is an extra energy source is kept there and it is adding to it, because divergence at that point is there. Divergence means divergence at a particular point means at that point we have kept extra energy source and it is adding to the actual energy, so energy that is flowing in that direction, it is adding to it or it is subtracting to it. Means there is a hole there and there it is sucking the energy, or there is energy that is adding to the energy. Negative kind of divergence means it is sucking the energy. Positive divergence, it is adding to the energy. That is a divergence. Now the biggest question arises is, what is the divergence of a velocity? Divergence of a velocity vector, divergence of an electrical field, that is 0. Divergence of something is 0 means, I have already given example. Consider electrical field is minus xi plus y by 2j plus z by 2k. If you settle it down, df1 by dx plus df2 by dy plus df3 by dz, it becomes 0. Minus xi plus plus y by 2j plus z by 2k, it is 0. Means 0, just 0. Everywhere it is 0. Take any point in the space, and if you start feeling the electrical field, then if this is x-axis, this is y-axis. If I take any point, consider this is the line that is parallel to x-axis. This is the line. This is the point I have taken. This is the origin. This is the point. In way, this is x-axis direction. This is y-axis direction. This is z-axis direction at that point. Along the x-axis direction, minus xi, liquid is coming towards this point, minus xi. Y by 2j, liquid is going out from this point. Z by 2k, liquid is going out from this point, positive. In that sense, minus xi plus y by 2j plus z by 2k means whatever liquid is coming to that point, equal amount is, half of them is going along y-axis and half of them is going along z-axis. That's why divergence is 0 there. There is no energy source. It is just behaving like a router. Whatever energy field is coming, it is getting distributed out there. What about minus xi plus yj plus zk? Now divergence is there. Minus 1 plus 1 plus 1, 1. If you take any point, it is constant 1. Take any point 2 comma 2 comma 2. Any point, there it is 1. 1 means whatever energy coming from x-axis, that is negative divergence. And then whatever same energy is going towards y-axis, so nullified. But extra energy is going along the z-axis, that is 1. Okay, means at that 2 comma 2 comma 2, there is some energy source kept out there. Anyway, then what is this way? Divergence is 0. Divergence is 0 means your velocity field or vector field or energy field, okay, force field, whatever, electromagnetic field, electric field, whatever it is a algebraic vector. If you see minus xi plus yj plus zk, it is algebraic vector. But if you calculate the divergence, df1 by dx, df2 by dy plus df3 by dz, if you add all three, if it becomes 0, means if you take along all three axes, and x-axis, y-axis and z-axis, whatever amount of liquid that is coming to that at that point, that is called negative divergence, is normalized by whatever is going out. Their divergence is 0. This is one way of considering divergence is 0. What is another way of considering divergence is 0? If your velocity field is a constant vector, it is going in one direction only, like any ai plus bj plus zk, 2i plus 3j plus 4k, there is a velocity vector and it is going in one direction only. It is not changing anywhere. What do you mean? It is changing in xi plus yj plus zk. Yes. If you take along x-axis, then y is 0, z is 0. Then it is going like towards the origin along the x-axis. If you take y-axis, then it is coming out from the y-axis. If you take z-axis, it is coming out from the center origin toward the z-axis. All where direction is different. If I say 1 comma 2 comma 1 comma I comma j comma k, if that is a vector, you take any point, it will be constant in one direction. I comma j comma k means numeric vector is a single line vector, whereas algebraic vector will keep changing if you change x, y, z. That's why it is algebraic vector, variable vector. Someone can algebraic vector or variable vector. If that is the scenario, it is if you have a constant vector, then df1 by dx 0, df2 by dz, df2 by dy 0, df3 by dz 0. If that is the case, then net flux density is 0. Divergence is 0. If that is the case, then for any closed surface, the net flux coming out is 0. Because if I calculate divergence from the I can calculate divergence flux density from the flux itself. Flux itself in the sense that for any velocity vector, the flux density or divergence is net flux divided by the volume. Net flux divided by the volume, or divergence df1 by dx plus df2 by dy plus df3 by dz, or net flux divided by the volume. But if I know the flux density, it may be algebra. I'm not saying it will be constant. If I know the flux density, I can get back the flux density into d of volume, not into volume, d of volume. What is the meaning of d? D in the integral calculus, I have shown it very clearly. The volume vector, the flux density into d of volume. This proves that flux density is a dependent component on some independent component. That's why d is coming in between. Flux density into d of volume vector, is net flux. From flux I can calculate flux density. From flux density I can get back the flux density into the volume is the net flux. That is flux density d of volume. If it is in Cartesian coordinate system, then flux density, if it is in algebra or whatever it is, multiplied by d volume, dx d by dz, and for this volume what you have taken, now take the limit of x, y and z. That will be the net flux. Now, if divergence of a vector field, or velocity field is 0, I know it is 0, then prove that for any closed surface or any volume kind of thing, any closed surface, net flux will be 0, guaranteed. For this only I have given this big lecture. This is a very big milestone. If I know divergence of an electric field is 0, it is not diverging, it does not have any divergence. This is divergence free electrical field. Or at a particular point, it is 0. Then around that point in a symmetric way, if I take a closed surface, then flux there will be 0. That is the question. Can anyone solve it? If divergence of a velocity field, velocity vector, electrical vector, whatever, if it is 0, guaranteed that it is 0, then prove that if it is 0 at all, like r vector, like if there is electrical charge and its velocity vector is q, r vector divided by r to the power 3, q r vector divided by r to the power 3. If that is the case, then it is divergence free. If you do df1 by dx, that is q into r vector xi plus yj plus zk divided by r to the power 3, x square plus y square plus z square to the power 3 by 2. df1 by dx, df2 by dy, df3 by dz. If you calculate and add it, it becomes zero. This is divergence free electrical field. Okay, if this is a divergence free electrical field, then if I take any volume, if I take any volume inside which this force field is defined, otherwise force field or velocity field, if I say qr vector divided by r to the power 3, at the origin it is not defined, because at the origin denominator will be 0, it is not defined. So I cannot take any sphere any sphere which is centered at the origin. If it is centered at the origin, then at the origin this velocity vector is not defined. In that case, I cannot calculate the net flux is flux density into volume. If I'm calculating the net flux is flux density, or that is divergence, into the volume, then inside this full volume, the velocity field must be continuous. It is not continuous at the origin, no problem. If electrical charge is kept at the origin, I am taking a closed surface somewhere here. Okay, all right. Now, inside this closed surface, full electrical field is defined. There is no divide by 0. In that sense, still divergence of the electrical field is 0 all where then the flux that is coming out of it is 0. Okay, means whatever the liquid is entering from here, same amount of liquid is coming out of here. That is the net flux is 0. Can someone prove it? Okay, if divergence of an electrical field is 0, then it has two reasons. We have demonstrated it well. Two reasons. One reason is if it is an algebraic vector or variable vector, then df1 by dx plus df2 by dy plus df3 by dz, if you df by dx is not 0, df1 by dx is not 0, df2 by dy is not 0, df3 by dz is not 0, but if you add them it becomes 0. So at that point, net divergence, if you add all three, at that point it is behaving like a router. Whatever the electrical field is coming at that point, it is going out equally. This is one way of saying that divergence is 0. Or electrical field is a constant vector, then also divergence is 0. df1 by dx to a constant is 0, 0, 0. Okay, now if divergence is 0, plainly I can consider, even though my electrical field is an algebraic vector, but divergence was 0, I can blindly take now that my electrical field is a constant vector. My electrical field is a constant vector. If electrical field is a constant vector, then in a closed loop, in a closed surface region, a constant vector base, here the electrical field is same as here. All the point electrical field is in same direction. ai plus bj plus zk, I plus j plus k, 2i plus 3k plus 4j, 4i plus 3.5j plus 5k. Whatever you take, if you take a numeric vector, it is constant in one direction. If you take a numeric vector, velocity vector, which is constant in one direction, if you take a closed surface, then whatever it will enter, same thing it will exit. Prove it. But one thing, no, my velocity vector is not constant. It is a variable vector, whatever it is. Your divergence is 0, right? If your divergence is 0, then I can take it as it is a constant vector, because at the end divergence is same. If there is a constant vector, can someone prove that if the velocity vector is a constant vector is constant, something like there is a liquid that is flowing in one direction, full liquid, means in a pipe it is flowing. It is not going like electrical field, it is going like distributed like this. If you see electrical field, then it is distributed like this. Or if there is a current line, there is a wire and current is flowing like this, then electromagnetic wave will be in rotating fashion. Okay, electromagnetic wave will be in rotating fashion, and that is again some constant r vector divided by r square. This is what I believe, not r to the power 3, r square. That is the formula. It will be rotating around it, but still the velocity vector is not straight line, it is rotation. Can you see? It would be minus yi plus xj divided by, I'm sorry, it is not r vector by r square, it is minus yi plus xj. that is r theta vector, r theta unit vector divided by x square plus y square to the power x square plus y square. R square means x square plus y square. That is the, but it is rotating, means it is an algebraic vector. It is not a straight vector. It is rotating. Minus yi plus xj divided by x square plus y square. Okay. But if I know divergence of an electrical field is 0, then I can say, electrical field is as good as when I am calculating the net flux because of the divergence or because of the flux density. The net flux is flux density into the volume. Where flux density is 0, divergence is 0, then calculation of flux is divergence into dv. When divergence is 0, net flux is 0. But can you prove it with the actual flux calculation? That is the velocity vector dot product with the area vector is the actual flux calculation. Another flux calculation is, if you know the divergence, then into dv, there is no vector here, dv is the flux. That is also one way, that is another way. If I say my divergence of a vector is 0, then through the first way, that is the vector dot area vector, that is the flux calculation, it will be always be 0. In theory way, I can say, if there is an electrical field that is going exactly everywhere, it is in one direction only, that is a constant vector. When it is passing a closed surface, then whatever will enter, same will exit. Whatever will enter, same will exit, guaranteed. Okay, but there is no guarantee in mathematics as long as you are not proving it. So, in that sense, what I am trying to say is, I have a velocity vector f, an area vector a vector, f dot area vector, where area vector belongs to a closed surface. Area vector belongs to a closed surface. When area vector belongs to a closed surface and there is a velocity vector f, then f dot area vector of a closed surface will always be 0 if divergence of f is 0. If divergence, what is your f? I don't know what is my f. I don't bother. If divergence of f is 0, then f is as good as any numerical vector. Then I can say f is ai plus bj plus zk. ai plus bj plus zk dot product with the area vector. If you take a sphere, then area vector is dz by dx minus dz by dxi minus dz by dyj plus k dx dy. This is full is the area vector. If you do, now can someone prove it that ai plus bj plus zk, this is a constant velocity vector because its divergence is 0. It may be some algebraic vector. I don't bother. When divergence is 0, it comes in a family of constant vector only. Any constant vector ai plus bj plus zk dot product with the area vector, any closed surface area vector, it can be a cube, it can be a sphere. Area vector in Cartesian coordinate is minus dz by dxi minus dz by dyj plus k dx dy. That is the area vector. Dot product will give the flux as 0. Okay, I can give a hint. If it is too difficult, then it is not a bad idea to calculate the, instead of doing dot product with the area vector. If I have, this is two dimension, on two dimension there is a circle kept and there is a velocity vector. Velocity vector is numerical vector ai plus bj, and a velocity vector is now passing through a circular line. It is a closed loop only. Prove that its dot product is 0. Same it will come if this velocity vector in 3 dimension, it is passing through a surface, then dot product of the with the area vector of the closed surface will be 0. It is analogous to if there is a vector in 2 dimension and it is passing through a closed loop, then the dot product will be 0. ai plus bj, ai plus bj. What is the kind of dot product if I take the 2D? That is the vector, velocity vector or force vector dot product with the d of position vector. So that is ai plus bj dot d of xi plus yj, where in circle y equal to a square root of a square minus x square, or it will become d of position vector xi plus yj. Please watch our previous video on curl, I believe. In this section only vector and commercial calculus. Now if you settle it down, ai plus bj dot d of position vector, then d of position vector is xi plus yj. D of position vector is same as dp by dx into dx, same. If you do like this, then d of position vector is xi plus yj by dx, I plus dy by dx, I plus dy by dx, j into dx. It becomes dxi plus dyj, ai plus bj, a dx dot product means ij gone, a dx plus b dy, where y belongs to a closed loop is 0. Can someone prove it? A dx plus b dy is 0, where y belongs to a curve which is closed. If I take a circle, then y is square root of a square minus x square. Then it is a dx plus b minus xy square root of a square minus x square dx. Okay, will it be 0? A dx, if I take dx out, then it becomes a minus bx divided by square root of a square minus x square. Then it becomes a square root of a square minus x square dx minus bx divided by square root of a square minus x square dx. Okay, a square root of a square minus x square minus bx, okay, whole divided by square root of a square minus x square dx. Since it is a closed loop, then we can divide into two integrations. One is from 0 to pi and another from pi to 0. Can someone try it? Okay, I can do it. Better we let's break it into a kind of polar coordinate system. X equal to a cos theta and y equal to a sin theta. Okay, we change it to polar coordinate system. Then dx equal to a minus sin theta d theta, and dy y equal to a sin theta, dy equal to a cos theta d theta. Now we can replace a dx plus b dy as a. Anyway, consider the radius is 1. For time being, radius is 1. So x equal to cos theta and y, to make it, otherwise 2a will come into the picture. X equal to cos theta and y equal to sin theta. Radius of circle is 1. So the radius is gone. Now if someone settle down a dx plus b dy, it becomes a minus sin theta d theta. A minus sin theta d theta. Another will become b cos theta d theta. If someone integrate it, someone has to integrate it, minus a cos theta d theta plus minus a sin theta d theta plus b cos theta d theta minus a sin theta. If you do integration, then it becomes a cos theta only. This is why I believe so. And there it becomes a sin theta whatever. Now you set 0 to pi, whatever it comes, set pi to 0, they will be opposite to each other and it will become 0, guaranteed. Okay, someone can try in x also. If someone done with it and it is guaranteed 0, then there is any numerical vector that is crossing a 2D closed curve, then crossing any numerical vector. Numerical vector means it is not changing. It is constant in one direction. Any numerical vector is crossing dot product with a closed loop is 0. If that is the case, then can someone prove the any velocity vector dot product with the area vector, closed area vector is 0. If someone take it, then area vector, the closed product area vector is, if you remember, dp, velocity vector dot d of p, the way we did. D of p is same as dp by dxy plane into dxy plane. That is dp by dx cross dp by dy. If the force vector, velocity vector is ai plus bj plus zk, then dp by dx cross dp by dy becomes minus dz by dxi minus dz by dyj plus k. Okay, if you settle down this dot product, it becomes minus a dz by dxi minus b dz by dy minus a dz by dx plus minus b dz by dy plus c, whatever is there, dx dy. Integrate it on the limit on the xy plane, that is a circular region. Okay, that will be, if it is, we have taken a sphere, then x will be minus a to a, x will be minus a to a, and y will be, since it is circular region, minus a square root of a square minus x square to square root of a square minus x square. That will be a limit. Or someone is free to change it into spherical coordinate system and try, if the velocity vector is a constant vector, numerical vector dot product with any surface area vector of a closed surface will always be 0. If someone proves it, then we will do much bigger thing that we will see. Don't mind supporting us. These are our way to explain the idea. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.